In previous videos, we spoke about relative extrema, relative minimum, relative maximum. So for example, we said here we have a relative minimum, here we have a relative maximum. What we want to find out now is the absolute maximum and minimum values of a function in a given interval. If the value of the function at some point x of 0 is greater than or equal than any other value of the function in some interval I, we say that f has an absolute maximum at that point in that interval. For example, if we consider the interval I closed from A to B in this graph, then f has an absolute maximum here because the value of the function at that point is greater than any other value of the function. Here we have a relative maximum, but this is the absolute maximum. It's the greatest of all the maximums. And it has an absolute minimum at D because the value of the function at D is less than or equal than any other value of the function. We are going to consider three cases for absolute maximum and minimum. The first one is for functions, continuous functions defined on a finite closed interval. The second one would be for functions in infinite intervals. And the third case would be for functions on open intervals. This is the first one. If a function is continuous and it is defined on a finite closed interval, then it has to have both an absolute maximum and an absolute minimum. This is called the extreme value theorem. Extreme value theorem. And when you look at the graphs, it's pretty obvious. If the function doesn't have any holes or any gaps, and it is defined in a closed interval, then it has to have both a maximum and a minimum, an absolute maximum and an absolute minimum. In this case, this function has an absolute minimum at A and an absolute maximum at B. In this case, there is an absolute maximum here at this point C, which is a stationary point, by the way. And this would be the absolute minimum here. And in this case, we have an absolute maximum here at this point C, which is, by the way, where f prime is undefined. So how do we find the absolute maximum and minimum points in a finite closed interval? The absolute extrema, the absolute maximum and minimum, could happen at the ends of the interval, could happen at stationary points, or could happen at points where the derivative is undefined. So how do we find the absolute maximum and minimum? First, find the critical points. Find the critical points in the open interval. Second, evaluate f at the critical points and the endpoints. Critical points and the endpoints. And then, in step number 3, the largest value found in step number 2 is the absolute maximum, and the smallest is the absolute minimum. Let me give you an example. Let's say that we want to find the absolute maximum and minimum values of this function on this interval. First of all, this is a polynomial, and therefore it is continuous everywhere. So it will be continuous in the open interval, in the closed interval from 1 to 6, and therefore it has to have an absolute maximum and absolute minimum. So what are we going to do? What we are supposed to do, first of all, is find the critical values, find the derivative, right? The derivative is going to be 3 times 2 is 6x squared minus 42x plus 60. And we can factor that as, let's say that we factor 6, that multiplies x squared minus 7x plus 10. And we could also factor this, which is x minus 2 times x minus 5. And what we want to do is find the critical point. So find the values that make the derivative 0 and find the values that make the derivative undefined. But the derivative is also a polynomial, so it's never going to be undefined. Now, if we make this 0, then we are going to find two values, x equals 2 and x equals 5. And x equals 2 is in this interval, and x equals 5 is also in this interval. So they are critical points. And according to the procedure that I just gave you on the previous page, what we have to do now is evaluate the function at the critical points and the endpoints. So all we have to do is find the value of the function, not the derivative, the value of the function at this endpoint, the value of the function at that critical point, the value of the function at the other critical point, and finally the value of the function at the other endpoint. And if you do that, you're going to find plug 1 on the function, and you're going to find, I already did that with the calculator, that is going to give you 41. And if you plug 2 on the function, that's going to give you 52. And for 5, I got 25. And for 6, I got 36. So the largest value is this one. So this is the absolute maximum. Absolute maximum. And the smallest value is the absolute minimum, which is this one here. If you have access to a graphing calculator, you can take a look at how the function, the graph of the function looks like. Just go to y and put in there 2x raised to the third minus 21x squared, which is right there, plus 60x plus 60x. Okay, get out of there, second quit. And then we saw the values of the function. That will give you some idea for the window. For the x's, we can choose from 0 to 8, right? So I can go to window, and the minimum I'm going to say 0, and for the maximum I'm going to say 8. And the minimum value for y I could say 0, 0, and the maximum probably, let's say 60, and then the graph. Okay, and we see what's going on. You see that what we found matches the graph that we get in the graphing calculator. The absolute minimum happens at 5. 1, 2, 3, 4, 5. Here we have the absolute minimum. And the absolute maximum happens at 2. 1, 2. Here you have your absolute maximum. The second case that we will be dealing with about absolute maximum and minimum is for functions on infinite intervals. Let's say that these functions are defined from negative infinity to plus infinity. What I mean by this dot dot dots is that this goes on and on in both directions, okay? If we see that the limit of the function when x approaches negative infinity, when x is going in this direction, is plus infinity, and the limit of the function when x approaches plus infinity is also plus infinity, if you see the values of these two limits, that means that what is happening is this, and therefore the function will have an absolute minimum but no absolute maximum. Similarly, if we see that the limit of the function when x approaches negative infinity, when x is going this way, the limit is negative infinity, that means the function is going down, and when x approaches plus infinity, the function is also going down, the limit is negative infinity, then the function will have an absolute maximum but no absolute minimum. For the other two cases, if the limit when x approaches negative infinity is negative infinity, and the limit when x approaches plus infinity is plus infinity, what is happening is something like this, and the function will not have an absolute maximum or an absolute minimum. Similarly here. Let me show you an example. Let's say that we want to find out if the function f of x equals 2x to the fourth plus 3x cubed has any absolute maximum or minimum on negative infinity to plus infinity. So what should we do? Let's calculate the limit of the function when x approaches negative infinity, and also the limit of the function when x approaches negative infinity, positive infinity, I'm sorry. And we will see if what is happening is this, or this. Okay? So when x approaches negative infinity, since x is raised to the fourth, this term is going to be positive because it is a negative number raised to an even power. So this term here will be approaching plus infinity. And when x approaches negative infinity, this is an odd exponent, so this term is going to be approaching negative infinity. The question is, who wins out of these two terms? Who dominates? And the answer is this term dominates over the other one because it has a larger exponent. So for values of x that are sufficiently large in the negative direction, this term is always going to be bigger than that one. So this limit is plus infinity. And when x approaches plus infinity, this is approaching plus infinity, this is also approaching plus infinity, and the limit is plus infinity. So what is happening is something like this. When x approaches negative infinity, the function is approaching plus infinity. So something like this is going on. When x approaches negative infinity, when x is going in this direction, the function is going up. And when x approaches plus infinity, the function is also going up. So something like this is happening. What is happening in the middle? At this point, we don't care because the question was only, does this function have an absolute maximum or an absolute minimum? And the answer would be yes, it does, because what we have is a situation like this. So the function will have an absolute minimum. So what we should do now is find the derivative to find out the critical points. The derivative is going to be 8x cubed plus 9x squared, and we can factor x squared that multiplies 8x plus 9. And if we make this equal to 0, we're going to find x equals 0 and x equals negative 9 over 8. And are there any values that make this undefined? And the answer is none. Okay, so this is a critical point, and this is also a critical point, negative 9 over 8. So we already know that the function doesn't have an absolute maximum because it keeps going up and keeps going up. And we are interested in finding the absolute maximum or minimum. There is no absolute maximum. So at one of these 2 points, we will have our absolute minimum. All we have to do is evaluate the function at 0 and evaluate the function at negative 9 over 8. If you evaluate the function at 0, when you plug 0 here, you're going to get 0. And when you evaluate the function at negative 9 over 8, you plug negative 9 over 8 here, negative 9 over 8 there. I already did it with a calculator, and you get approximately negative 1.067. So this is our absolute minimum, and there is no absolute maximum. The third and last case of absolute maximum and minimum is for functions on open intervals from, let's say, a to b. So let's say that we have a function like this. So what is happening there? If you find the limit of this function when x approaches a from the right, when x is coming this way, and we get plus infinity, and we evaluate the function, the limit of the function when x approaches b from the left, when x is going this way, and we find that it is also plus infinity. We see that these 2 limits are plus infinity. What is going on is that. And that means that the function will not have an absolute maximum, but it will have an absolute minimum. Something similar happens here. The limit of f of x when x approaches a from the right gives us negative infinity. And the limit of f of x when x approaches b from the left gives us also negative infinity. So what is happening is this: the function is coming down, so there will not be an absolute minimum, but there will be an absolute maximum. In these 2 cases, what is happening? The limit when f of x approaches, the limit of f of x when x approaches a from the right gives you negative infinity. When x approaches b from the left, gives you plus infinity. So that means that the function is not going to have an absolute maximum or an absolute minimum. Similarly here, no absolute maximum, no absolute minimum. Let me give you an example. Let's say that we want to find the absolute maximum and minimum values of this function, f of x equals 2 over x squared minus 9x, on this interval from 0 to 9, an open interval from 0 to 9. What should we do? Find the limit of the function 2 over x squared minus 9x when x is approaching 0 from the right. X is approaching 0 from the right. So if x is approaching 0 from the right, let's do this. Let's factor this. Let's factor an x that multiplies x minus 9. And then when x approaches 0 from the right. When x approaches 0 from the right, this is going to be positive, this factor here. And this is going to be negative. Therefore, the whole thing is going to be negative because this is positive, positive, negative, so it will be negative. But the denominator is approaching 0 because x is approaching 0, right? So all of this is approaching 0, therefore the whole thing is approaching infinity. So what we get is that the limit when x approaches 0 from the right is negative infinity. Now, what is the other limit? The other limit that I have to calculate is the limit of the function 2 over x times x minus 9 when x approaches what? When x approaches 9 from the left, from this side. 9 from the left. If x is approaching 9 from the left, notice that x is not approaching negative 9. It is approaching 9 from the left, so x is a positive number. If x is approaching 9 from the left, that means that x is less than 9. Minus 9 is going to give me a negative number. So again, this is positive, positive, negative, so that's going to give me a negative number. And this whole thing is approaching 0, therefore the whole fraction is approaching infinity. So we get negative infinity, so what we got was this, which means that the function will have an absolute maximum but no absolute minimum. So we have to find it. So if we need to find the absolute maximum, what we need to do is find the derivative to find the critical point, right? So let's use the quotient rule there. The derivative of the top is 0 times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So we get negative 2 times 2x minus 1 over x squared minus 9x squared. And to find the critical points, what we have to do is make the derivative 0. If we make the derivative 0, in order for the fraction to be 0, the top must be 0. So that means that 2x minus 9 must be 0, and we get x is equal to 9/2. And to make the derivative undefined, the bottom should be 0. And the bottom is x squared minus 9x, that should be 0, which means x times x minus 9 should be 0. And that is going to give us x equals 0 and x equals 9. Now this point, 9/2, is in the given interval. So this point is a critical point. Now 0 is not on that interval, neither is 9. So 0 is not a critical point, and 9 is not a critical point either. So the function, we already know that the function is going to have a maximum but no minimum. So the maximum happens here. So we should say at x equals 9 over 2, f has the absolute maximum. The absolute maximum. The absolute maximum, and all we have to do to find the maximum is take that number and plug it into the function. Okay, and that's it.